So we're going to introduce something called the Pythagorean identity, but first, let's just do a totally unrelated and isolated problem. Okay, example 2. If the sine of some angle is 3/7 and t is in the second quadrant, find cosine of t. So let's draw a picture, okay? Whenever you can draw a picture in Trig, and in most math, it's a good idea to do it. So t is somewhere in the second quadrant, which means over here. I don't know where, I don't know how big t is. We haven't figured that out yet. So just draw something anywhere in the second quadrant. It doesn't matter. Okay? Well, then remember, if we think about this as a point on the unit circle, right? If we think about this as a point on the unit circle, hypotenuse is 1. There is an x coordinate that we don't know. There's a y coordinate right here. So this point, we don't know that much, but we do know that the sine is 3/7. Okay? Maybe let's not use the unit circle here, actually. Let's make it a little easier on ourselves. We won't use the unit circle right here. If the sine of t is 3/7, then we can think of a triangle as this. We could also, scale this down to make it on the unit circle, but you don't have to. You can have unit circle, the 7th circle. That's not what it's called. I don't know what the unit circle with radius 7 is called. Probably just the circle with radius 7. Okay. Well, then notice that this point is going to be the x value, comma, the y value. But in this case, we don't know what the x value is. If we knew the x value, we'd know cosine, right? Cosine of t is the x value if it's a unit circle, which again, it's not the unit circle right here. But we could scale it back. So what we're going to do is we can find this side length right here by using Pythagorean theorem. Okay? So what does a Pythagorean theorem say? It says that this x value squared plus the y value squared equals the hypotenuse squared. You could use a unit circle here, but you'd get fractions, and I don't like fractions, so that's why I'm not using it. So if we just solve this for x, we're going to get x squared plus 9 equals 49. Let's subtract 9 from both sides. And then we're going to get that x squared equals 40. If x squared equals 40, that means x is either positive or negative square root of 40. Which, if you want to use the exact answer, this is going to simplify down to 2 square root of 10. Now, which one is it? Is x a positive number or a negative number? How do we choose which one it is? Well, we're in the second quadrant. I know the x value has to be negative in the second quadrant. It's negative because quadrant 2. That's not how you write an A. Right? X is negative over here, right? If we're to the left, x is negative. So I do know the answer is going to be the negative version. So we're going to say x is negative 2 root 10 right here. So this point up here is the point negative 2 root 10. But because I didn't use a unit circle this time, this is not the answer for cosine. If we use the unit circle, the x coordinate would be cosine. But we're going to have to actually use a triangle right here. Okay? So cosine of t is going to be the x coordinate, which is negative 2 root 10, divided by the hypotenuse, which is 7. And this is something that we're going to talk about in this video. By introducing something called the Pythagorean identity. This is more of an introductory example. It shows one method of doing this problem. We're going to also show another method of doing this problem once we introduce this next thing. So let's hold that thought for a little bit. This example. We're going to do another example, and then we're going to combine these two examples to kind of show something cool. Okay, so get ready. One more example, and then we're going to put them together to get something awesome. In what quadrants are sine of t, cosine of t, and tangent of t positive? This seems like kind of a weird question, Jason. Why are you asking this question? Where's this question coming from? How am I supposed to know the answer? Well, let's look at the unit circle. In each quadrant, let's just pick a point in every quadrant. Doesn't matter where the point is, just pick a point in every quadrant, right? On the unit circle, so let's unit circle right here. Remember, on the unit circle, the x coordinate is the cosine of t, the y coordinate is the sine of t, and tangent of t is just sine over cosine, y over x. Opposite over adjacent. So to answer this question, we really just have to look at these three things. So sine, let's answer down here, right? Sine of t is the y value. So it's positive. Where? Where is the y value positive? Which one of these points has a positive y value? Well, y is vertical. So these two have positive y values, and the other two have negative y values. So sine is positive when those two are positive in the first and second quadrant. And we can do the same exact logic for cosine, right? Cosine is the x value. So it's positive in what quadrants? We'll look at the x value. X is to the right. X is positive to the right. So these are the 2 points with a positive x value. That's quadrants 1 and 4. Let's do the same thing for tangent. Tangent of t is the y over x value. This doesn't quite work out as well. So where is it positive? So let's look at y over x. When is this positive? It's positive when they're both positive or both negative, right? A fraction is positive when the top and the bottom are both positive, or when the top and the bottom are both negative. X and y are positive here. X and y are both negative here. This is where tangent's positive. 1 and 3. So here, let's fix this problem right here real quick. And I want you to be able to see behind me. Essentially what we have right here, there we go, this is much better. We're gonna have a little a ghost professor. There you go, now you don't miss a thing. Spooky trig, okay? So tangent is positive in the first and the third, cosine's positive in the first and the fourth, sine's positive in the first and the second. Let's summarize this data. I actually kind of like this. We're gonna do this for the rest of the video, okay? The rest of the video is gonna have spooky Jason. All right. So let's summarize this. Everything's positive in the first quadrant, and then sine in the second, tangent in the third, cosine in the fourth. We can summarize that. So in summary, that's not how you spell summary. No, let's do it even bigger. Let's draw a big thing. All trig functions are positive in the first quadrant. Trig functions are positive, all of them in the first quadrant. It was only sine in the second quadrant. It was only tangent in the third quadrant. It was only cosine in the last one. So one way that we remember this is ASTC. And there's some cool little initialisms or whatever that you can use to remember this. Remember where things are positive. 3 years ago, my trig students came up with the genius idea that we should remember this by all squids train camels. You can thank the trig students in Washington. Nope, that's where I live now, in Wyoming, for this. Okay, my high school teacher who taught trig said all seniors take calculus. Some of you might be taking calculus. That might be useful as well. But however you want to remember this, it tells you which trig functions are positive in which quadrants. All of them are positive in this quadrant. Only sine, only tangent, and then only cosine in that quadrant. All squids train camels. All right, so let's introduce the Pythagorean identity, finally. So, I'm going to blow your mind right here. If I have a right triangle, like this, you may be familiar with the Pythagorean theorem. A squared plus b squared equals c squared. You may have seen this before. Well, watch this. You ready? Watch this, watch this. Same triangle, right? But if we're on the unit circle now, what is A? It's x, otherwise known as cosine of t. What is y? Y and b are the same thing, otherwise known as sine of t. And what's the hypotenuse on the unit circle? 1. So if we look at the Pythagorean theorem, on the unit circle, what do we have? Sine squared, sine of t squared plus cosine of t squared equals 1 squared. That's called the Pythagorean identity. Okay, so sine squared of t plus cosine squared of t equals 1. This is called the Pythagorean identity. Because again, sine squared, well, real quick, right? This is an important note. Sine squared is just shorthand for this. So when we write sine squared of t, that just means sine of t squared. This is what we're actually meaning, but nobody wants to write that many parentheses. So this is the shorthand. Okay, so watch out for that. And again, this is just another way of saying y squared plus x squared equals the hypotenuse squared. Okie dokie. So let's revisit example 2. Revisit example 2 with this theorem. So, what was example 2? It's kind of been a while. So we said that sine of t equals 3/7, and then t is in quadrant 2. Well, now that we have some nice little mathematical sorcery, this problem gets a lot easier. Watch this. Pythagorean identity. Sine squared of t plus cosine squared of t equals 1. And again, remember, sine squared of t just means sine of t squared. So as a side note, right? This right here is just whatever sine of t is, and then square it. But sine of t is 3/7. So what this becomes 3/7 squared plus cosine squared of t. So if we want to find cosine of t, let's just solve for cosine of t. Let's get the cosine of t by itself and solve. So if we square 3/7, we square the numerator, we square the denominator. And again, remember, this is the same as cosine of t squared. We need to get everything together, so let's subtract 9/49 from both sides. That's going to leave us with cosine of t squared equals, let's rewrite 1 as 49/49, and then we're subtracting 9/49. Spooky. I knew this would come in handy again. Spooky math professor. And then let's simplify the right-hand side a little bit. 49/49 minus 9/49, we now have 40. 49. If we square root both sides, let's copy this down real quick, right? We have cosine of t squared equals 40/49. I'm just copying down the last step. If we take the square root of both sides, well, then on the left-hand side, the square root cancels with the square. And the right-hand side, we always need a plus or minus. Square root of 40 divided by the square root of 49. The square root of 49 is just 7. And then again, it's quadrant 2. Is cosine positive or negative in the second quadrant? Well, let's go back. All squids train camels. In the second quadrant, only sine is positive, so cosine's negative here. Negative. We're going to say that cosine of t equals negative, simplify the square root of 40 again is 2 square root of 10, divided by 7. And that's another way of solving that problem, okay? And I jinxed it. This video is actually much longer than I thought it was going to be. But here we are. Let me know if you have any questions. And hopefully I will return to full corporeality by the next video. I think that's the word. Bye-bye.